Okay, this is part two of my grading alignments and profile course. I was having a hard time deciding which one should go first, whether it's profiles or surfaces. Um, Both can be watched in whatever order. I'm going to post them around the same time. So if you happen to watch the profiles video first, great. I recommend watching this one afterwards. If not, either way, both videos will get you what you need to know. So this one is going to be on surfaces, surface edits, and feature lines and feature line creation. So to start off, if you are working in the construction slash civil industry, you'll hear people mention surfaces. Surfaces are um, elevation data for your drawings. Generally, it comes from a surveyor. Sometimes you can get the information from like your local county or jurisdiction, whoever may have that information. You can even get it from U.S. Geological Survey. They have some information that's made public. So you may also at some point hear tin surface. Tin surface and a surface is the same thing. A tin surface, tin stands for triangulated irregular network, which basically means that there are lines in your surface that create a triangle, and that triangle is what is used to make your elevation data and your surface. So that is kind of a hard thing to understand. So the best way to explain it would be to show you. So right here I have my surface. This one came from local county. Um, so this is just, each one of these are contour lines. These all represent an elevation. In this case, this one is 5,280 feet above sea level, which would be zero. So yeah, so this is my surface. So I'm going to go ahead and change this and turn on my triangles. So it looks like a lot. Typically you will not be looking at this, but this is how I can explain what a tin surface is. So as you can see here, we have a line, and a line. So that makes up one triangle. So each one of these lines that you see here, these gray lines, all of these end up making up a triangle, one singular triangle, and they're all connected together to create our 3D surface. And when we hit a major elevation or a minor elevation, so either 2 feet, every 2 feet, or every 10 feet in this case, it draws a contour line, which this white line here is a contour line, and we have some 2 foot contours. So that is going to be, so that one's 5,228 feet. And this one over here is going to be 5,230 feet. So it is 2 feet in elevation difference from this line to this white line. So that is a tin surface. Surfaces can be created from many different things. So typically, when you're doing final design for a civil project, you would be getting elevation data and existing ground information from a surveyor. And a surveyor will likely give you something that looks similar to this, but it'll be made of typically survey points or Kogo points. Kogo points and AutoCAD points are different. They should not be confused because Kogo points have more information. They're a Civil 3D specific object. So they could be made from Kogo points, they could be made from survey figures. So survey figures are a series of Kogo points that are connected together with a survey figure, which is similar to a feature line, to create an existing surface. They can also be created with a DEM, which stands for Digital Elevation Model, which I will show you here shortly. They can also be created with polylines that have elevation data to them, or in this case, contour lines that are not already a surface. They can also be created with feature lines, which we'll talk about more later on. And those feature lines will be considered a break line. They can also be made of grading groups, which grading groups will be the, in this case, part 4 of this training series. I'll explain what grading groups are. And then part 5, I'll be talking about, or part 5 will have grading groups and corridors. So a corridor is a little bit more detailed and a little bit more complicated, so that will be later on in this video series. So to show you what a DEM is, so this this right here is an image. So as you can see, there is some line work through there. You can see different shades of color. This image here represents elevation data. The darker it is, the lower it is, the lighter it is, the higher up it is. So this image here was used to create these contour lines. So let's take this section here. You can see that these lines are really far apart. This would be a road in this case. That is going to be this right here. And you can see this little circle, like almost teardrop shape. That is going to be this right here. That is a teardrop. So a DEM, or a digital elevation model, that is created with LiDAR imagery. And typically you could get that from your local jurisdiction, or you could even get that from GIS people doing that magic over there. So that is a digital elevation model. And so from this specific digital elevation model, they gave me polylines with elevation information. So that is going to lead into my next section here, which is surface creation. So in this case, I'm going to start out with, I'm not going to go over how to create a surface through a DEM. That's a lot more complex, and it's not something that's commonly done, at least in my case. So I've only done it a few times. So I'm going to talk about it with polylines. So this DEM, they extracted polylines with an elevation. So this one can be rounded up to 5,342 feet. And each one of these lines here that you see is a polyline with elevation. The ones that are white are typically intermediate. Could be one, they could be a minor contour or major contour. Any of those would be what they're called. So in order to create a surface, we'll have to go into our ribbon under the ground data panel. You'll find surfaces. So we'll do the drop down, and you can see that we have all of these different options. So we're going to start with create surface. And in this case, I'm going to create a new layer for it. So let's say I'll make new, and I'll name it EG. Let's see. X for existing dash EG for existing grade. And then I'll hit OK. Hit OK. And the surface name, so this is going to be the name that you give your surface. And I'll call it existing grade. And the style is, in this case, for this specific drawing, I only have one. I don't have any styles added into this, but I can show you different styles in another drawing here shortly. So I'm going to go ahead and hit OK from here. And now this will this will lead into our next topic, which is surface edits. So in order to view where your surface information is stored, you're going to have to open what is called Toolspace. So you can see right here in your in your ribbon under the palettes panel, you're going to click Toolspace. So in my case, I have it docked off to the right. So that'll show up with something like this. And this is going to be open drawings. So it'll show you all the information in this LiDAR clip. Then I have this other drawing open. I have my data shortcuts and drawing templates. So if I look through this list and I find surfaces and expand that, here's my existing grade surface that I just created. I'm going to go ahead and expand that. So I have some masks, I have watersheds. Not going to talk about those. Those are more complicated topics. For now, just the basics. I'll expand definition. So right now you see that there's nothing here. There's no way I can expand any more of these. So in this case, I'm going to want to create a surface out of contours, which in this case I have as polylines with elevation. So I'm going to go ahead and select contours, right click, add. So now you can add a description if you want. So this would just be a way to describe what these contours are. So the weeding factor would be weeding out extraneous information. It's simplifying your surface. For now, I'll change this to 10 for now. And supplementing factor, I'm going to be honest, I don't know what the 100 feet stands for. But for the mid-ordinate distance, it's going to create a line for a triangle at 1 foot along each one of these contours. I'm going to change this to 0.5, a little bit closer, more triangles, so a cleaner surface, a more accurate surface. So minimize flat areas by filling gaps in contour data, swapping edges, adding points to flat triangle edges, add points to flat edges. So I'm going to stick with the default. By default, it has these 3 checked. So I'm going to leave it at that. I'm going to hit OK. And then now it's asking me to select contours. So I'm going to go ahead and just highlight all of my objects. So there's 109 lines that it found. I'm going to go ahead and hit enter. And you can see now that there is a line that was created, a yellow line around here. So what that yellow line is my boundary of my surface. All surfaces have a boundary, and that is represented in this case with this yellow line. That's how I can tell where the edges of my surface are. So since I added those contours, they still exist in my drawing. It didn't get rid of them like alignments. When you create an alignment from an object, you have the option of deleting it. In this case, it does not delete it, keeps it in the drawing. So what I'm going to do is I'm going to go ahead and freeze those. And in this case, my style standard is not a great style. So very quickly, I'm opening a blank drawing, which will open up the Autodesk default template. I'm going to go to the Settings tab in Toolspace. I'm going to scroll down where I find Drawing 2, which is this drawing I just created. Go to Surface, Surface Styles, and now I have these. So this is contours at 1 foot and 5 feet. So every foot it's going to put a minor contour, and every 5 feet it'll put a major. But I don't necessarily want that. I'm going to do every 2 feet it'll put a minor contour, every 10 feet it'll do a major. So I'm going to click on this and drag it over. You saw that little symbol next to my cursor that is adding that style to this drawing. So now, since I have my surface with no information on it, it's going. I'm going to go over to my properties and find style. I'm going to do the drop down and change it over to 2-foot and 10-foot contours. And in parentheses, they had background. So there's design and background. Design, typically by default, will show up plot out black, and background will plot out gray, which is typically what you want to see when on an engineering drawing when you're doing final design. So now, as you can see, all those contour lines that I initially had now are showing up in my drawing as a tin surface. So, some quick things. So I'll go over some more information on surface edits. I'm not going to go into too much detail quite yet, just because this is a very basic explanation for now. For boundaries, if you wanted to ever add your own boundary, we can quickly go over this. So I'll draw a rectangle over this area. So let's say I wanted only my surface to show up here. I'll go to Toolspace, I'll go over to Boundaries, right click, add, and name. Let's try temp underscore BNDY for temporary boundary. I'm going to set the type to be outer, non-destructive, so it won't damage the surface in any way. It won't change the elevation at any point. It won't do anything. It's just going to take that as my outer boundary of my surface. Again, I'm going to do my mid-ordinate distance to be 0.5 feet. I'm going to hit OK. And then now it's asking me to select an object. So I'll go ahead and select that. And as you can see, the rest of it disappeared, and this is now my boundary. So that's another edit that you can make to tin surfaces. Now, if let's say since it's a temporary boundary, I don't want that boundary anymore. So I'm going to select boundaries, and at the bottom down here in my tool space, I see my temp boundary. So I'm going to select it, right click, delete. Do you want it to be removed? Okay. So now you can see that you get this little triangle here. What that triangle is telling you is that your surface is out of date. Something has been changed on your surface, and it needs to rebuild the surface in order to show the most up-to-date version of your surface. So in order to do that, we're going to select on our surface in Toolspace existing grade, right click, and go to rebuild. I'm going to select that, and you can see that now my temporary boundary is gone, and my entire surface is back. I'm going to go ahead and delete that temporary boundary line that I had created. So the next thing in this list is break lines. Break lines, like I mentioned earlier, are feature lines that now is part of your surface. And one way to think about break lines is if you had a piece of paper and you were to fold your piece of paper at any point on your piece of paper or on that paper, that fold line that you have is now a break line. So if you were to take your paper again and fold it in the opposite direction, now you have a fold in two different directions. Those are two break lines. And you could pull them up slightly, you can move them around, but those quote-unquote break lines are going to stay where they're at. Those are your points and your elevation points that you have. So those can be created with feature lines, and we'll talk about that here momentarily. We've already talked about contours. Next is DEM files. So if I had that image ready to go, I could load that DEM image into this edit and add that in, and it'll create my DEM surface. So I can also add drawing objects. So if I had a polyline, let's say, that had an elevation, maybe I wanted that to be part of the contour, then I could add that in. Other edits that you can make in here, as you can see here. So if you right click on edits, you can add a line, and the line that they're talking about is a tin line. So one of those triangle lines. So you could add one of those. You can delete some of those lines. You can swap edges. This is not something that I personally have had to do, but it will change how the surface is built. You can add points to your surface. You could delete points. You could modify points. You could move points. You could minimize flat areas. So when we created the surface through the contour lines, we had all those options about minimizing flat areas. So that's where you can modify it and edit your surface to change how those flat areas are built. You can raise or lower your surface. So if, let's say, you had a final surface that you did with all your grading on, and you realize, oh man, it is a foot too low. You can use that to raise your surface. You can smooth it. So maybe you raise the mid-ordinate distance from 0.5 to 1, or maybe you make it with more triangles and you make it from 0.5 to 0.1. You could simplify the surface so it'll take away triangles, or you could just refresh it. So those are the various edits that you can make to surfaces. You could add point files. So point files are going to be coming from the surveyor. When the surveyor's out there, some of you may have seen this just out and about, that you'll see some construction workers with a yellow tripod and somebody else with another pole. What those are, that is your surveyor, and they are getting points from those two things. And those point files will be loaded in to your drawing and used to create your surface. Point groups, when they bring in those points, they can group them together to, let's say, group it in curbs and asphalt and, let's say, planter boxes and utilities, and they group all those together so they can just import the utilities or just import the curbs. Point survey queries, I have a hard time saying that, and figure survey queries. Those two are, again, going to be from survey. I've never personally done anything to do with point files, point groups. Any of these four I have not personally done. I have never worked in the survey side. I have an understanding of some of a workflow for that, but I have not personally done it. So those four are going to be for surveyors to deal with. So that is the other thing. The last thing I want to mention is, or a couple more things on surfaces. My apologies. Another thing that you can do, and I have done this many times. Let's say we have a situation where we have multiple different roadways that we did grading on, and to minimize the file size, we did one grading in one file and another grading in another file. We bring those two gradings together, and we create a brand new surface. With that brand new surface, we can go to this option here, which in my case, I only have one surface, so it's not an option for me. But I can go to paste surface, and I can paste both of those two surfaces into my brand new third composite surface to create one final combined surface. So that is another edit that you can make. You can paste other surfaces in to make one giant surface. And the last thing that I want to mention with surfaces is, if you were to select your surface, right click and go to Object Viewer, it'll bring up this window here. So you can see your cursor is now different. It is kind of two different circles intertwined, whatever you want to call that. So that is allowing you to orbit in 3D space. So I'm going to go ahead and click and drag, And you can see now that my surface is in fact 3D. But a tin surface is not 3D and has elevation and a volume to it. It just has a 2D surface. It is just a flat surface representing the Earth, the section of the Earth that you have elevation data for. So in my specific surface, you can see a roadway here. You can see that it kind of slopes up and we kind of have a high point, like a ridge somewhere in here, and it kind of goes downhill there, downhill this way. And in this object viewer, you can change the different look of it. So in this case, I'd change it to conceptual. I can change it to hidden. So I'm just seeing the boundary and some of the lines within it. We could do realistic. So this is going to be a more realistic look of what you're actually seeing there. And then we have shaded, which looks very similar. It's basically the same as realistic. We have shaded with edges. So now you can see your triangles in here. So you got all your lines for your triangles. And then we have shades of gray. So now instead of having your edges, you just have, it just changes the shades of each triangle to be different colors so that you're getting viewing the elevation difference. We have sketchy. This one's always been weird. I've never found anything helpful from this one. We have wireframe. So this is, instead of being colored in, we're just seeing the triangles, and it's more of a wire look. And there's X-ray. I personally hate the look of this. This is very bright and very ugly to me to look at. So this is Object Viewer. This is super helpful. I use it all the time. My personal favorite to use is either shaded with edges or shades of gray. This is good because when you're doing your grading, you can use Object Viewer to look at your surface and see if you have any issues and where those issues are located. So again, just to show that again, you'll select your surface, right click, and go down to Object Viewer. So that is surfaces. Surface creation and surface edits. So now we're going to quickly go over feature lines and feature line creation. So let me go over to this. So a feature line, so let's take these two lines here. This line here, you can see it's a polyline with a bunch of vertexes throughout, and you can see that AutoCAD and Civil 3D represent a polyline as a straight line. You can set an elevation, but both points are going to be at that one elevation. You can't set a different elevation for this point or this point or this point. This point and the start point and the end point are the only ones that can have an elevation. And that elevation is going to be consistent throughout the entire line. So you can't have a varying size. You can't change the elevation halfway through. You can't do anything. It's just one elevation straight through from start to end. How feature lines fit into this is a feature line. You can think of a feature line as a polyline that allows for different elevations throughout at each vertex. Or in this case, we will call them elevation points. And I can't think of the exact naming. I'll show it here in just a second. But this would be a good representation. So this is just a polyline, but if it were a feature line and you looked at it from the side, we can set an elevation that is different across each one of these vertex points. So a feature line is a polyline that each vertex point can have a separate elevation, and you can modify that elevation as you want. So in order to create a feature line, so we'll have a polyline in, if you're looking at it from the top, you can have it go in any direction. It could be a curve, it could be a straight line, anything like that. You could have multiple vertexes making it go in different directions, however, but it just has to be a polyline or a line. So from your ribbon in the Create Design panel, we'll go to Feature Line, and we'll do, so you can either create a feature line. I have almost never done this personally. I generally have a polyline already drawn. So we'll go down to Create Feature Line from Objects, and now it's asking, as you can see here, you can select lines, arcs, polylines, or 3D polylines to create feature lines. So I'm going to select this polyline right here. I'm going to hit Enter, and now it's asking me for the site. Again, I'm not going to discuss sites, but if you have one created, then you can add it here. So I'm going to leave it as standard, and later on you can change the site that the feature line is on, but I'm going to leave it as standard for now, and it's going to go on layer 0, and in this case I'm just going to leave it, and I'm going to have erase existing entities. I always have this one selected, this box checked, because I never want two lines on top of each other. If I am getting this line work from a proposed site XREF that's just 2D line work that represents the curbs and the sidewalks and the parking stalls and anything else, then that's going to be in a completely separate drawing. That I'll copy that information into my grading drawing. I never want to have a feature line on top of a polyline that are exactly at the same points. That's just messy and poor practice. And if you want to, you can assign elevations to this if you have elevations, or you can weed points. In this case, I'm not going to assign elevations, and I'm not going to weed points. So now when we select this, it no longer shows up as a polyline in your properties. It shows up as a feature line. So within the data for the feature line, you can see that it's on site 1, number of points. So 1, 2, 3, 4, 5. We have PI points, which is what I was referencing earlier. Instead of vertexes on feature lines, they're called PI points, points of intersection. It gives us elevation points. We have 0 because we have not added elevation points because we can have a PI, a point of intersection, or an elevation point. I've many times been discouraged from using elevation points. In the past, they have been the cause of file corruption, so be cautious when you're adding elevation points. Next thing that it shows is the 2D length and the 3D length. So in this case, if you were to show the 2D length from this point to this point, it would be that X feet long. Whereas if you showed the 3D length, this now adds, it makes it longer, this makes it longer, this makes it longer. Each one of these lines, individual line segments, makes that feature line longer. So you may have a time where these 2 points will be a foot in elevation difference, and now your 3D length for this feature line is going to be different. It's going to be longer than your 2D length. And it'll show you the area. So if it's a larger enclosed feature line, like a closed, similar to a closed polyline, but if it's a closed feature line, then it'll show you the area in square footage, square feet. It'll show you the minimum and maximum elevation, the minimum grade, which is going to be percent slope. So think back to algebra with y equals mx plus b, and just rise over run. So whatever that ends up coming out to be, it'll show you the minimum and maximum grade. So for now, for this video, that is going to be all that I talk about with feature lines. Come back for part 4, where I will go into more detail and explain how feature lines are incorporated into grading. Thank you for watching my video. If you have any questions, please let me know in the comments. And if there's anything that I said that was incorrect, please let me know. Please let me know in the comments, and I will happily revise what I said. I'm still learning. I'm by no means an expert, at everything, but I do know a lot about Civil 3D, so I am here to share my knowledge, and I hope that you will share any knowledge with me that you may have that in places that I misspoke. Thank you for watching, and come back for the next part where I talk about profiles.